Hi everyone, I am Kumar. Welcome to today's video. Let's get set and learn. Today we will be understanding basic pillars of OOPS. Let's start. Today we will explore four fundamental pillars of object-oriented programming language: inheritance, polymorphism, encapsulation, and abstraction. Each of these topics is very crucial to understand and maybe directly asked in interviews. So in interviews you might get questions like explain inheritance, explain encapsulation, explain polymorphism, like this. So these are the topics that are directly asked as interview questions. And finally we will also see differences between encapsulation and abstraction. Sometimes this is also asked as interview questions. Now let's start with inheritance. Let's understand the meaning of word inheritance. In everyday life, inheritance refers to characteristics that we inherit from our parents. So if you see this example, you can tell that this child's hair is like his mother's. This child's eyes may look like his father's. So this property is called inheritance. Okay? So similarly, in world of object-oriented programming language, you can inherit methods and attributes of a class from another class. Okay, let's see the definition. It is the mechanism by which one class is allowed to inherit the features of another class, fields and methods. What are we inheriting? Fields and methods. Let's see an example to understand. Okay, this animal class, we have an animal class. This animal class has name, attribute, and it also has eats and sleep function. So every animal has name, every animal can eat and sleep. Okay? So this is a class. Now what we want to do, we want to implement a cat class from this animal class. What we can do, we can just use keyword extends and inherit all these names, eats and sleeps from animal class. So cat now inherits name, eat and sleep from animal. Similarly, you can create a lion class. Lion also inherits the same thing. And you can create a cow class. Cow also inherits the same thing. So what have we done? So this inheritance allows us to utilize the functionality of animal class in this class, cat class. So we have declared two functionalities, each and sleep, and we have also declared name. This can be utilized in cat and cat class, lion class, and cow class. This process is called inheritance. Now here, this animal class is called parent class. These classes are called child class. Now let's understand polymorphism. So polymorphism is derived from two words. Poly means many, morphism means forms. This is a Greek word. Polymorphism is a Greek word which means many forms. So what is the definition? Polymorphism allows objects of different classes to respond to the same method call in different ways. Let's understand this with an example. Okay. Now let's see this example first. In the previous example, we have seen an animal class, cat, lion, and cow can be inherited from an animal class, right? Now you want to implement a sound functionality. Cat sound is meow, lion sound is roar, and cow sound is moo. You want to implement that functionality. Okay. Now you have implemented sound method in each of these classes. Now you have implemented the method name is same sound. So whenever you create a line object, let's say, and called sound, it will return roar. But now you create a cat object and you call sound method, it will return meow. So the function is same, but based on which object it is called, it is giving different functionality. So now let's see the definition back again. Polymorphism allows objects of different classes to respond to the same method call in different ways. So we have objects of different classes. Now it is responding to the same method call in different ways. This type of polymorphism is called runtime polymorphism. We will understand this in more detail in future videos. There is another type of polymorphism. Here, let's take an example, add. So we can add two numbers using this function, or we can create a function by which you can add three numbers, or we can create a function by which we can add two double. The function name is same, but based on what we pass to the function, let's say we pass a add 2 comma 3, then this function will be called. If we pass add 2 comma 3 comma 4, this function will be called. If we pass add 2.1 and 3.1, this function will be called. So based on argument type, now different function is called. This is also called polymorphism. This is compile time polymorphism. So polymorphism here means taking many forms. Same function sound, same function add is taking many form based on different object it is acting on or different different attributes it's called on. So based on that, it will take different forms. Okay. The important part is function name is same or method name is same, whatever it is, like the thing should be same, but what it is called on, it will behave differently. That part is called polymorphism. Okay, we'll see one last example. Let's imagine a draw function. Okay, now if you are passing triangle to the draw function, it will draw a triangle. If you are passing circle to a draw function, it will draw a circle. If you are passing rectangle to a draw function, it will draw a rectangle. So based on what shape you are passing, it will draw that shape. Okay, similar to this add function. This is called polymorphism. I think polymorphism is clear now. Let's see encapsulation. So encapsulation is a concept in OOPS that describes wrapping or bundling of data and methods in a single unit. So it is like creating a capsule in which you put all your attributes, instance variables or attributes or whatever it is called, and all methods, and put a bundle, like create a class out of it. This part is called encapsulation. For example, we have a person class. Okay, we can encapsulate person's name and age attributes along with how we act, along with few methods that can change name or change age or maybe do some other functionalities. So based on the functionality, we can manage this data name and age in a controlled manner, preventing some like unintended modification. For example, let's say you have provided this person class. In you have given access so that people can modify their name and age. Okay? Now what someone can do, someone can enter their age as -2. Is it valid? No. So what you can do, you can give control that if age is less than 0, you cannot modify it or you cannot add the value to it. So you can do this in a controlled manner. This is called encapsulation. You can encapsulate your data and methods in a controlled manner. So what is encapsulation is used for? It is used for data access protection. It can be used for code modularity. So you can create bundle all the functionalities in a class, and you can like all the data patterns can be design patterns can be used to encapsulate things in a class. So this is the use case. Now let's see abstraction. Then we will see the differences between encapsulation and abstraction. That will make it much clearer. Abstraction in OOPS is used to hide unnecessary information and display only necessary information. For example, take this remote. You have a TV, you have a remote. From the remote, by seeing the remote, you can tell that this is the power button. These are the numbers button that can be used to change channel numbers. These are menu options button. Somewhere here there might be volume up down button. So from the remote, by seeing buttons, you can tell what functionality it does, what this button does, but you don't know how it does. Do you know how that one button can be used to just switch on and switch off TV? So most of the people don't know. So this hiding unnecessary information and displaying only what it does, that is called abstraction. So in our real world, most of the things that we do are abstracted to us. We know what it does, but we don't know how it does. For example, laptops, mobile apps. So in laptop, you access a website, let's say. You open browser and just click a link, enter a link, it will access that website. You don't know what is happening in the background. You just know there is a bar in which if I type the link, that website will be appearing in front of me. So that is abstracted to you. Okay, and maybe you in mobile apps you might play game. So in game, this button is used to move the player forward. This button is used to move the player right. So you take the joystick and do all those things. Let's say FIFA game. Okay, now the joystick. You know from the joystick that these are the buttons that does this, but you don't know what code is written in the background that actually does this. Okay, so this part is called abstraction. Your most of the things are abstracted to you. So in case of object-oriented programming, abstraction means you just show what your class does, what are the methods, what are its input parameters, but you don't know how those methods are implemented. You can show what are your attributes. Okay. So what is the use of abstraction? Abstraction helps in reducing complexity. So you just have to, and it is making us easier to understand the class. So we know what these function does from the function name or from the input arguments, or maybe some documentation might be there. Okay, but we don't know how it does. That is not important. And you can have these abstract classes, and you can inherit from those classes, like extend those abstract classes and write your own functionality. So from this abstraction, now you know that you have to implement these and these things, these methods, and you can implement in your own way. You don't have to think about what and all you have to implement, because you know that these are the things I have to implement. So what it helps, abstraction also helps in reusing the code easily. Okay, so these are the some uses of abstraction. Now let's see main difference of encapsulation and abstraction. We have seen that encapsulation also does some hiding things. Abstraction also does some hiding things. So this might create some confusion that how is abstraction different from encapsulation? Okay, let's see the differences. So we will see based on 3 points. Okay, first let's see on focus point of view. Encapsulation focus on providing functionality by bundling attributes and methods. But abstraction focuses on what is being provided, what functionality is being provided. It does not show how it is being done. So that is the focus of abstraction. Okay. So we know that encapsulation and abstraction hide something. Let's see what it hides. Encapsulation hides internal attributes. So it might not give you access to few of the attributes so that it can control. Like the example we have seen is age. Okay. But abstraction hides implementation. So internal implementation. It does not show how a method is implemented. Okay. Now let's see why we are hiding this. In encapsulation, we are hiding to protect uncontrolled access. So in encapsulation, you need not hide all members, all attributes. So you might hide only the one which you require based on the functionality you want to provide. Similarly, in abstraction, we hide to make the code easier to understand, make the code easier to reuse, all those things. So this is the main difference of encapsulation and abstraction. Abstraction gives us information of what is being done. It removes how it is being done. Encapsulation hides some things to protect uncontrolled access. So you can think it's like very different, but it is doing some hiding. Abstraction is also doing some hiding. Okay. So I think encapsulation and abstraction is clear now. Okay. That's all, folks, for today. We will learn this in much detail in implementation level through code in later videos. Okay. What we have seen what is inheritance, what is polymorphism, encapsulation, and inheritance, and few examples of each of these. We have seen some differences of encapsulation and polymorphism. That's all, folks, for today. Thank you.